Hello, this is Miss B. It's Friday, so I hope you're having a good day. All right, I hope you are working on this warm-up. When Hans multiplies 4 6/10 by 8 3/10, his answer is 3,818 before he puts in the decimal point. What is his final answer? Discuss this with your shoulder partner, how you know. Okay, so my suggestion when you have multiple choice questions is to eliminate answers that don't make sense. So we have more than 4 times more than 8. Could the answer possibly be 3? No. 38? Possibly. 381. Let's think. What's 4 times 8? 32? Is it going to be in the hundreds? No. And then is it going to be in the thousands? No. Right there, just by eliminating answers that don't make sense, the only one left that's close to our answer would be 38 1800ths. Okay, so we are in the multiplying decimals portion of this unit, and we have worked on multiplying decimals in the past. So this is just a reminder. So 1, we need to make an estimate, always. Then we take out the decimals and solve the problem. Good news for all of you that do not like the generic rectangle, you may use standard algorithm for this, for the multiplying decimals portion of this unit. But standard or generic rectangle is great for all of those kiddos that like it. Then after you get your answer, you put your decimals back in using your estimate and double checking it by counting the number of spots after the decimal. And we'll practice that now. Okay, so it says solve these with no calculator. So this is a no calculator unit. And we have 5.5 times 3 4/10. So we can't multiply a fraction times a decimal. And decimals are easier to multiply than fractions. So we are going to change our fraction into a decimal. So I am hoping that most of us remember that 1/2 as a decimal equals 0.5. So this would become 5.5 times 3.4. Now that we have our equation set up, we have to do that first thing. We have to do our estimate. And remember, what we do is we just take the numbers in front of the decimal for our estimate. So we have 5 times 3, and that's 15. And we know it's a little bit more than 5 and a little bit more than 3, so our answer is going to be close to 15, but larger than 15. Then we're going to remove the decimals altogether, and our new problem is going to become 55 times 34. All right, so I'm going to do one standard algorithm and one generic rectangle, and then after that, you're going to solve them however you want. So when you're doing the standard algorithm, for those of you that don't use this method but maybe want to try it, you first do 4 times 5, and that's 20. So you drop the 0, carry the 2. Then you do 4 times this 5, which is 20, plus 2 is 22. And the whole 22 goes down here because we have no more numbers. Now, then I like to cross out the things we don't need anymore. So cross this out because we used it. Cross out the 4 because we used it. And then we're going to place a placeholder 0 in the ones place because we've already done the ones place. Now we're going to take this 3, and because we have our placeholder 0 down there, we don't call it a 30. We just pretend it's a 3. So 3 times 5 is 15. Drop the 5, carry the 1. And then 3 times 5 is 15 plus 1 is 16. The whole thing goes down here because there are no more numbers. And you add these together. Okay, so our estimate is 15. So I am thinking that the only thing that makes sense is to put the decimal point in between the 8 and 7 because 18 is the closest to 15. Then I'm going to go back up to my original equation and I'm going to count how many numbers are behind the decimal point as my final check. So we have 1 5 here and a 4 here. So that's 2. So 1, 2 numbers need to be behind our decimal. So 18 and 70 hundredths should be our answer. Then let's quickly just do a generic rectangle just as a reminder for those of you who haven't done it for a while. So our number is 55. So we have 55 times 34. So we'll put our equations in our box. 30 times 50, 30 times 5, 4 times 50, and 4 times 5. And then we'll start in the top left-hand corner. 3 times 5 is 15. Add 2 zeros. Circle your answer. Next box, 3 times 5 is 15. Add 1 0. Circle your answer. 4 times 5 is 20. Add 1 0 for an answer of 200. And last, 4 times 5 is 20. Now this is always the part where we make silly mistakes because we don't line our numbers up very carefully. So be very careful with this. You want to line up the ones place. And we got the same number, 1,870, and we would do the same process. 18 is the closest that we can get to 15. And we've got 2 numbers behind the decimal. Okay, so we're going to try these, and you can use your favorite strategy, partial products, generic rectangle, or standard algorithm. So we have 1 45 hundredths times 4 fifths. So we cannot leave that 4 fifths. So the first thing we have to do is we have to convert that to a decimal. And the way to do that is your denominator either needs to be a 10 or a 100 or a 1,000 because we have the tenths, hundredths, thousandths place behind our decimal point. So we're going to look at the denominator of 5. Well, we know that that goes into 10. So we can multiply by the giant 1. We'll put 2's in there. 4 times 2 is 8. 5 times 2 is 10. 8 tenths equals 8 tenths. So our new equation is 1 45 hundredths times 8 tenths. Let's do an estimate. So we have 1 times, now we have 0.8. And I don't know if you remember from the last unit where we did this, but whenever you have a number with no whole numbers, just a decimal, we always just round it up to 1 because we don't want an estimate of 0, right? And anything times 0 is 0. So we have 1 times 1, our estimate is going to be close to 1. But we know that it will be bigger than 1 because 1 45 hundredths is bigger than 1. Now I want you to just take the time to do this any way you want. Either set it up as generic rectangle or standard algorithm. And remember, our new equation would be 145 times 8, because you have to pull the decimals out, and then we'll put them in after. Go ahead and try this. Okay, so for an answer, I got 1,160. So I know I need an answer that is close to 1. So the closest I can get to that estimate is 1.160. But I do, especially, this is when counting your decimal points in the original equation comes in handy, because multiplying by a decimal is always a little tricky. So I'm going to go back up to my original equation. I have 1, 2, 3 numbers behind the decimal. I'm going to go down to my answer. 1, 2, 3. We did it correctly. All right, good job. All right, let's look at this. 2 3/4 times 1 7/10. Now, we've been talking about this for a while. When you have that denominator of 4, we're going to be thinking about 4 quarters in a dollar. So, but we don't have 4 out of 4 making it 1, which would be the $1. We have 3 quarters. So how much are 3 quarters? How much money is that? Hopefully you guys are saying 75 cents, because that is correct. $2.75. times 1.7. So let's go ahead and make our estimate. We have 2 times 1. So our estimate is going to be close to 2, but it will be larger than 2 because this is $2.75 is more than 2, and 1.7 is more than 1. We're going to take the decimals out to make our equation. So it'll become 275 times 17. Go ahead and do that in any way you want. Okay, I got the answer of 4,675, and my estimate is 2. So I'm thinking that I'm going to have to put that decimal right behind the 4 because 2 and 4 are very close together. Then I'm going to do my counting decimals from the original equation. So I'm going to go right up here to the original equation and count the numbers behind the decimal. 1, 2, 3. 1, 2, 3. Yay, I did it right. I hope you did too. Okay, what do you think is the best strategy to solve this problem? Pick it and solve. The price for 1 ounce of Sour Patch Kids is 15 cents. A box of Sour Patch Kids holds 14.5 ounces. What is the cost for this box of candy? So we need to multiply that 14.5 ounces times 15 cents because it's 15 cents per ounce. So we're going to first make our 14.5 look like a decimal. So 14.5 times 0.15. So let's make our estimate. So I've got 14 in front of the decimal there. I have a 0 here, so I turn it into a 1, and our estimate is approximately 14. We can now solve our equation. We have 145 times 15. Go ahead and solve that any way you'd like. All right, I got 2,175. I know my estimate is 14, so, and that is a 2-digit number. So even, you might be thinking, well, 14's not really that close to 21, but it is a lot closer to 21 than if I put my decimal here and I made it a 2, or if I put my decimal here and I made it $217. So if we put it right there, all right, we're going to try this. How can you pick the best answer choice? Do you see any you know are incorrect before you solve the problem? Tom cut a piece of string into 6 pieces that were each 8 4/5 centimeters long. What was the length of the string before Tom cut it? 46.2, 48, 48.48, or 52.8? Talk to your shoulder partner and discuss which one you guys think, and then we'll talk about it. Okay, so if I was looking at this, my estimate is going to be 6 times 8, but I know it's going to be a little bit bigger because it's not exactly 6 times 8. It's a little bit more than 8. And 6 times 8 is 48. So we might be tempted to say it was 48, but we know it can't be exactly 48 because we've got that. So we're going to cross that off. Whoops, I crossed the wrong one off. You guys got to keep me on my toes. Cross that one off. We know it has to be more than 46. And then these two are close. So we know it's going to be one of these. So then we need to solve for this, okay? So we're going to change this 4/5 into a decimal quick. So it goes 0.8. All right, so then our equation is 6 times 8.8. Our estimate is still 48. And then we can solve. So our equation is going to be 6 times 88. Solve any way you would like. All right, I got an answer of 528. 48 would be closest to 52. And then if I go back to my original equation, we have up here, I only have one number behind the decimal in the equation, so I only need one number behind the decimal in the answer. So answer D. So estimates can help you get there, but they may, some of us might have thought that it was 48.48, but so we have to be careful. Okay, so now it is time for your homework. I'm hoping that you have plenty of time to actually finish this worksheet and not have any homework for the weekend. Use your time wisely and get it finished. And have a great weekend, and I'll see you on Monday.